One of the tests that we can run with Excel is an independent samples t-test or a paired t-test. This particular test is run when you have two groups the same size and you're testing different issues to see if the result is the same or if they're different between the two groups. This particular sample, a clinical psychologist wants to investigate the relative effectiveness of cognitive behavioral therapy and psychoanalytic therapy on depression. This total sample size is 30, but it's split into two groups, a group of 15 and another group of 15. The first 15 receive cognitive behavioral therapy, the second 15 receive psychoanalytic therapy, and then 2 months after their therapy, the depression score is recorded. Depression scores range from 0 to 70, with 70 being a higher depression score, meaning the patient suffers from, the higher the score, the more the patient suffers from depression. First thing is to determine what your null hypothesis is and what your alternate or research hypothesis. The null hypothesis in this case would be that there will be no difference between the two different kinds of therapy, that the mean score of depression after 2 months of therapy, regardless of which kind is done, will be the same. The two sample means should be, in effect, equal or statistically close enough that there's not a significant difference. The alternate hypothesis, or the research hypothesis, is that they're not going to be the same and that we will see a depression score that is statistically significant between the two, will help us determine whether the cognitive behavioral therapy or the psychoanalytic therapy was actually more helpful in helping the patients with depression. If you have loaded into Excel the data analysis tool, then you can go to Data, click on Data Analysis. We're going to do a t-test paired to sample for means. The variable ranges that I have loaded in here are the ranges for the depression scores. For group 1 is for variable 1, and then for group 2 it's the depression scores for group 2. If you click OK, I'm going to actually click out of this because I've already run this, but if you click OK, then it will give you the results, giving you several different things that you can read off of this total results. And it'll put it on a separate tab on your Excel spreadsheet. It tells you at the top that it ran a t-test paired to samples for means. It shows the mean for the different variables. So the mean depression score for those who had the cognitive behavioral therapy was 56 after 2 months of therapy. The mean depression score for those who had psychoanalytic therapy was 45. Now, that's 11 different. Is that statistically significant for a difference, or is that not enough to worry about? Remember that your null hypothesis is that there is no difference between the two groups. Your alternate hypothesis is there is a difference between the two groups. This is a two-tailed test, since it's an equal and we're not looking at doing anything with greater than or less than. And this automatically, regardless of what we use for confidence level, in this particular case, our confidence level normally would be 95 or 97, 99%. In this case, the test results ended up being less than 1%. If we'd had a confidence level of 95% and the p-value resulted in something higher than 0.05, then we would say that the null hypothesis is valid, because at least for this sample, it didn't pull it out. But in the case here, with the p-value coming out less than 1%, regardless of what we had for our confidence level, it is statistically significant. We can throw out the null hypothesis. So the two groups are not statistically the same. If the depression score means a higher depression, that means the cognitive behavioral people after 2 months of therapy had a higher depression rate than those who had the psychoanalytic therapy. You're not making any judgments on what will happen in the future, but you're comparing two sample sizes with the therapies they had, and you're determining that they are statistically different. That's the purpose of this particular test.